All right, so let's have a look then. So the question on the sheet says, so this is like the second page. All right, so if you're in your book, so this is task B, questions 1 and 2. All right. Are you all right for paper, Hudson, or do I need to give you something?
I don't know. I'm just trying to see if I can figure anything out.
Okay. So we're going to solve. It says to solve all the sides on the triangle, I believe, doesn't it? It says find the missing lengths of the sides of the triangles without using Pythagoras' theorem. Okay. So which side of this one shall we work out first? What do you want to go for? The adjacent. Which one's that then? How would you describe, how would you name that bottom line? It is the adjacent, but how would you name it?
The base?
Using the letters on the triangle. We did do this briefly.
A and B.
Say again?
B and A.
Well, we wouldn't use the word and. We would just say BA or AB or whatever. Yeah, so we're going to work out BA, yeah, the side BA. That's what we're going to do. And BA, as you already told me, this side is the adjacent side, this side is the opposite, this side is the hypotenuse. So when we work out BA, it's important that we say BA, well, that's the adjacent side. That red isn't really working. Right. What would be a good colour? All right, so but remember the first thing I said to do was to write down, so we should do sa, ka, toa, all right, because that represents the ratios that you've got on that sheet, sine, cosine, tangent, right? Like I said, some people write it as S, so sa, ka. You'll see it like that, so remember it's a division. Okay. So what do we do? How do we go through the process of choosing the correct one?
See which one is measuring to.
Okay. So which one? Well, actually, I go with the one that I don't need and don't want. So I've got the hypotenuse. I want the adjacent. So the one that I don't want at the moment is the opposite. So for solving BA, anything with an O in it, let's forget about. All right. So actually, it's not sine, it's cosine. Okay. So we then know that we're going to pick that one out. The cosine of theta, which is the symbol for the angle, is equal to the adjacent side divided by the hypotenuse. Okay. So then we fill out the information. So the cosine of what angle? 30 is equal to adjacent, what should we call it? BA. Okay, we can keep it as BA, that's not a problem. Divided by 6. Okay. Now you guys were all really good at this on Friday, so what do I do to figure out what BA is? Yeah, this is the one where we multiply it by 6, isn't it? Because the unknown is on the top of the fraction, it makes it easy. So we multiply both sides by 6, so we end up with 6 lots of cos 30 is BA. So you just have to do that on your calculator now. So Milo thinks it's 5.2. Can we confirm? Or? Yeah? 5.2. 5.2 what? Centimetres. Yeah. So do you remember I said put it in, adjacent is 5.2 centimetres. Okay. We look at that and we do our check. So you're all about reflections at the moment in advisory, aren't you? So check that 5.2, it must be shorter than the 6. The 6 has to be the longest, so it's good. But it needs to be in the right sort of area. If it was like 0.6 or something, it'd be wrong. So that little check, I'm not 100% sure I'm correct just by doing that check, but I know I'm in the right area, so it might give me confidence just to move on. Right? If the number was really different, it might make me recheck my working. And it might be, right? You never know. If I can't find a mistake, we should move on. All right, so we found BA, okay, 5.2, but we're missing a side. It wants us to also work out CB or BC, okay? So we still need to find that. Now, for this worksheet, it does say don't use Pythagoras' theorem. Why not? What would you do in an exam if you had to solve all 3 sides of that triangle? What would your next step be to find CB? What would you do given any options? Why would you use Pythagoras theorem? Yeah? Why would you, Jane? What would you do?
Because you already know 2 sides and you decide.
Yeah, great. You know 2 sides. Want to find the third? That's Pythagoras' theorem, isn't it? Yeah? Is it an addition Pythagoras' theorem or a subtraction? Good, well done. Subtraction, because we know the hypotenuse. All right. So I would agree with you. I would go with Pythagoras' theorem, but they're testing you on your trigonometry here. So we have to do the other side using trigonometry this time. So let's do CB. Again, I'm going to write out SOHCAHTOA. Okay. Now the angle's still 30, so these opposite hypotenuse still stands. What would I use? So I want to know the opposite this side, this time. Say again? No, I'm still going to use my third. The right angle never comes into play other than if it's not right angle, I can't do this. Yeah? I'm still going to use the 30. This is opposite hypotenuse. Which of these can I use? Because I know the hypotenuse and I want to know the opposite. But here's the thing. I also know the adjacent. So I could use sine or TOA. Cos is no good to me because it's not got the opposite in it. Right? But I can actually use either of these now. Either one you like. Right? I've got enough information. And quite often with triangle questions, guys, they're like multi-step where you have to do several things, especially when you get into M4, M5 stuff. And you get to a stage where you've got so much information, there's lots of different ways to do it. Pythagoras' theorem, sine, tangent, you pick, you choose. All right? But one little piece of advice I'm going to give you. When you have an option of more than one way, my tip for you is choose the method that uses the information that is given to you in the question, not any answers you have come up with. So, for instance, I would not use the adjacent because I worked that out. So for me, that would cancel out tangent. Why do you think I would suggest that? No.
Because your answer might be wrong.
Good. Spot on. What if I made a mistake? Yeah. If I made a mistake in the first part, I'd be carrying that mistake on. Now that's not a huge problem because if you do that and you do the next bit correctly but with the wrong number, you still get all your marks. But sometimes a question is made easy by the numbers in it, and if you get a number wrong, that might make it slightly harder. Does that make sense? So if you can avoid using your... Sometimes it's not possible. You have to use your answer, and it will say, work out the next thing, right? And then say, hence, use your answer for the next part. Sometimes you can't avoid it, but in this case we can. But what I want to do, let's just check. Can I get, should we say, You four, this end, can you do the sine for me? And you three, can you do tangent for me? And let's compare our answers. So you guys are doing sine, you three are doing tangent. Let's see if we get the same answer. We should do. It's all going to be 30, yeah, that's the angle we've got. So you'll either have sine 30 is CB over 6, or you'll have tan 30 equals CB divided by 5.2. Either or. Right, because 5.2 is the adjacent, yeah, total opposite adjacent. Okay. So this is actually a really nice one because I know something about sine 30, and I know my M5 should know something about sine 30. And if you've done it on your calculator, just sine 30, you'll get sine 30 is actually one of the special angles, because what is sine of 30 on its own? Like, you just did it on your calculator, what did you get? What? 0.5. Exactly, yeah, not lots of decimals. So this is one of them where it's actually an exact number. Right, so that's really nice. Sine 30 is one of them. Right? So in this case, we should do 6 lots of sine 30 and you get 3. So CB should be 3. If you do this one, you should just have 5.2 lots of tan 30. What do you get? Exactly? Ah. Yeah? So, sorry, let me write that down. 3. Goes on, yeah? Now let me tell you this. This is the correct answer. Right? That's the exact answer. This one, it's almost right, but it's slightly off. It's not exactly 3. It's close enough, right? 3.0 is, you'd round that to 3. But why is it not exactly 3 when this one is exactly 3?
Because it's a decimal.
Yes, but why? Why do I get a decimal doing this one?
Because you multiplied it by 5.2.
Well, you're very close, but it's more than it's. The fact that it's a decimal is not a problem. Yeah? But there's something about that decimal. Sam? Yeah. Yes, but this isn't sine. Well, 5.2 times 0.5 would be an exact. It would be 2.6. But tan 30 is not 0.5. Sine 30 is. Now, this is a criterion D type question. Does your answer make sense? Yes, it makes perfect sense. What is the problem? Why are these numbers slightly different? The answer is something to do with this number. What did I say we should try and avoid? Using your own answer. And Niall said, quite correctly, which is exactly what I meant, there might be a mistake. There's no mistake. 5.2 is the answer. But can I just ask you to do 6 times cos of 30 again? We got 5.2, but what's the actual answer?
5.996152423.
What did we do? We rounded it. Alright? Which is perfectly acceptable, perfectly reasonable. I expect you to do it, but we rounded this answer. So therefore, this answer, the number that we used, has been rounded. Right? So it's not the exact answer. So what we have introduced in this case, guys, is a we have a small, what we call error. So what does error mean to you? Yeah, in maths it's not. An error is not a mistake in maths. An error is where it's slightly different from what you want it to, what it should be. Alright? So it's not wrong, but because we rounded it, we introduce what's called a rounding error. So it's slightly off. We've done nothing wrong, there is no mistake, it's just slightly off. And the reason is because this number was rounded. So when you are asked, guys, in a criterion D or something, does your answer make sense? Describe the degree of accuracy, that kind of, this is where you would say, because I've rounded this number, there's a slight error in it, and you know, that would be the ideal kind of answer. Does that make sense? Okay. So that's why we would use the answer, the numbers given, not our own rounded answers. Another reason. All right, how do you fit? Can we move on? You're good? Yeah, I think so. You seem pretty good. Let's have a look at the next questions then. All right, which is the next stage for you guys, which is finding an angle. All right. So give me a. All right. So we use the same process. We've got a right angle triangle. We've got an angle, but the angle is something we don't know now. So the angle is the thing that we want to find out. Right? I'm just going to change this colour, guys. I can't. Blue doesn't fit with any of my pen colours. Should we? Let's go back to black. That's better, isn't it? Good with everything. Okay. So you're presented with this question. You've never done it before, but you've got lots of knowledge and understanding about right-angled triangles. You know it's to do with trigonometry because you've got an angle and side involved. What would be the first thing that you would do? It's not Pythagoras' theorem, because Pythagoras' theorem has got nothing to do with angles. That's the big check, right? There are no angles, Pythagoras' theorem. There is an angle involved, not Pythagoras' theorem. Measuring, I see you doing that, Talia. But there's one reason we can't measure. And that's because it says at the very beginning of your sheet, note, triangles are not to scale. That means we can't measure. This side is not 8 centimetres and 4 centimetres, because that makes no sense, right? If that was 4 and that was 8, this one would be twice as long as that one. And it's not, is it? So not to scale, so we can't measure. It's all mathematics. It's all numbers, it's all calculation. But what should we write first? Always start with SOHCAHTOA. Let's write it. SOHCAHTOA. Oh. Easy to mess up. I keep switching, only because I want you to pick your own way of doing it. However you choose to write it, just write it. Yeah? All right, so we have to go through the same process again. So we need to select. So the angle is there. What side is this? That's the adjacent. This side is the opposite. This side is the... Right, which ones do I have and which one do I not want and don't know? So we cross out the hypotenuse, just like we did before. Which ones of these do we cross out? So we've got hypotenuse, so cross it, and we're left with top. Okay? So we can write down the tangent of the angle is equal to the opposite side divided by the adjacent. Again, you might think it's overkill. I'm writing all that, I don't need to, but I can check my work if I do this. Then I can fill the gap. So, tan, instead of theta, what can I write? X, good, is equal to, brilliant, super easy. Once you've labelled everything, you can super easy, you can check your work, you can see that you're doing the right thing, no problem. Alright. Now this is slightly different than we've had before, isn't it? Because we've been asked to find something in the ratio, and we've used the fact that tan of 30 is a number, yeah, to do the ratio, but we haven't got that now. So now we need a new little tool. Just like everything else in maths, there's always a way of undoing something, yeah? So it makes sense that if I draw, remember we did an angle, let's say it was 40 degrees. If I put a line there, I get a triangle. If I put another line there, I get another triangle. I get another line there, I get another triangle. All of them have the same ratios, yeah? That's what we came up with, right? Well, does it not make sense then? If I know the ratio, I should be able to work out the angle that it comes from, yeah? Because the angle sets the ratio. So if I know the ratio, I know the angle. It's just a matter of finding it. So how do we find it? Calculate, right? How do I know what I multiplied by? I divide by it. How do I know what I added? I subtract. Now on your calculator, I haven't got one on my screen, I need to download one, but have you got the sin, cos, sine, cos, tangent buttons, yeah? What do you notice written above them? So you've got sine minus 1 like that, cos minus 1, and those are your, do you know how to access them? Good, that's your second function for each button, for each second. So what we're going to do, these are called the inverse, blah, 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 alright? So it's the inverse sine, the inverse cosine, the inverse tangent. That's what we use when we want to know what the angle is from the ratio. So what I'm going to do here is say x is the angle that is created when I have this ratio. So I do the inverse tangent of 4 divided by 8. So you can put that into your calculator. So if you've got the TI-84s, I think you press your second and your tan button to get the tan minus 1. It probably puts that on the screen and gives you a bracket, yeah? You then just do 4 divide 8, close the brackets, press equals, and you get 26.5, let's have a look what you wrote in. Yeah, you've done sine there, not tangent. So what do you get? 20? So we always write a few extra, but when we have angles, normally we round them to 1 decimal place. That's the convention that we do. So we're going to round this to 26.6. We ignore the 5, the 6 rounds the 5 up. Okay, 26.6 degrees. And again, it's a bit harder with angles because it's not to scale, but we put 26.6 degrees in. It sort of makes sense. It's more difficult to check with angles. Okay. Now, on your calculator, guys, let me just do one thing. I don't know whether you've done this before. You have a DRG button at the top of your calculator. Alright? DRG. Have you ever experienced what happens if you press the button? What happens? So you'll see there's a little D, a little R, or a little G. It comes up on your screen if you press it, yeah? Well, you have to select, don't you? Do you get, does it say DG, RAD, and what's the other one? GRD. Alright. Do you know what they stand for? DEG, degrees.
Ratio?
Radians. Can't fit the rest in. Radians, I think. also unhappy for you at the moment. Right? Radians are another way of measuring angles. They're actually really super useful, but not till you get higher up in your maths. Can I just get you to put it onto radians for me and redo this question? What do you get? So, yeah, go across to radians, press enter, whatever, put the radians on. So if you do tan minus 1 of 4 divided by 8, you actually get 0.46. Alright? Radians. Whereas this one's in degrees. Now, that's not what you want. So that's a check that you must always do. Especially if you lend some funny person your calculator and they mess around with all the buttons. Can come back and it's in radian mode. And if you then start doing trigonometry, it only affects trigonometry, not your normal adding and subtracting, only when we're doing this angle stuff. Make sure your calculator is in the DEG, the degrees mode. Otherwise you'll get numbers like that. And I show you that because it will happen with sides and all sorts, the whole thing. If you get super small numbers, just check you're not in radians mode. Yeah? So then you press your DRG button. Try it with grades as well, if you like, but I only ever deal with degrees and radians, but yeah. Oh, you've got flow, so that's a number of decimal places, and it's something else. There's a lot of stuff on your calculator that I don't know how to use. Alright? But make sure, smiley face next to degrees, other two unhappy faces, you'll get wrong answers. Now, just so you know, if you are doing an assessment, for instance, and you get this as your answer, are you right or wrong? That's the thing, isn't it? You're right. Yeah. But I will mark it wrong unless I see all of this. If I see all of this written out, not this bit obviously, because you get that answer, I will then say, oh, they've done exactly the right working. I know what's happened. They're in radian mode. I'll give you your marks. And just make a little note on your paper saying you're in radians, change it. Alright, but you won't lose your marks. Maybe one for the first time for not checking. Alright, but you won't lose all your marks. What happens if you've not shown any working and you write this answer down? Yeah, I don't give you any credit. Alright, even though I suspect it's probably radians, I won't do it. Alright, so that's the example for that one. Make sense? It's not always going to be inverse tan. It's only inverse tan because of the ratio we chose. Over to you. You've got, what, 10 minutes to do one of the others. Okay.